In the last video, we saw how to build simple lists using generators. These allowed us to build a range of values, specifying a step size, an initial value, and then specifying the endpoint. These allowed us to build very simple lists, but today we're going to see how we can use them to build something more complicated using list comprehension. What is this? Well, it generally comes with this form here. So you can see I've specified out the shape that you'll generally want to follow when you're working with these. So what does this mean? Well, X are elements that are generated on the right hand side of this bar and meet the conditions on the right hand side. So we generate them by taking them from a generator or a range and then testing them for logical conditions. So for example, X will take the first value here. This is a list 1, 2, 3. So X will take the value of 1, we'll apply the condition 1 to it, condition 2, up to condition n. And if it meets all of those conditions, then it will become an element of this list. So X has to come from the generator or the range and then meet the conditions to form part of the list. So let's look at some examples. Let's do a simple one where we want to list all of the numbers that are divisible by 6 up to, say, 100. So we're going to use X as our double variable again. And we're going to say that X takes its values from the generator 1, 2 to 100. And then we need to test that it's divisible by 6. So we put a comma in, and that tells us that the next thing is either going to be another generator or a predicate. So X, and I'm going to use the infix mod notation here. So I'm going to say X mod 6 is equal to 0. Now these conditions can be as complex as you want, and there can be as many of them as you want, as long as they return a Boolean type. Haskell will be happy. So you could imagine using this notation, for example, with if you had a CSV file and you were using Haskell to build a list of, say, staff members that were part of a given department, or students who were on like the dean's roll or something like that. You know, this is just a simple way to check logical conditions are met. So if we save this and we, well, actually if we reload and then we do div by 6, we get all of the numbers that are divisible by 6 up to 100. Of course, this doesn't include 100 because 100 isn't divisible by 6, but it goes up to 100. Now we can make this more complex. So we could say this is div by 6 and 7, and we can add another condition in here and say that X mod 7 equals 0. So it's divisible by 7, and if I reload and then enter the same function, oh, sorry, I haven't renamed it, so it's 6 and 7. Then I get two numbers. These are the only two numbers from 0 up to 100 that are divisible by both 6 and 7. But as you can see, you can easily extend this to create more, to include more conditions as you go along. Now, you can also have more than one generator in a list comprehension. So let's look at a new type, and we'll say it's the tuple type. So a tuple is something of the form, let's say a tuple of integers, just so we have a simple type to work with. Something of this form. Of course, if you hit this and to enter, Haskell is okay with this. Haskell doesn't mind tuple types. You can specify them at the type level as you would any other type, but these are quite useful to work with. So let's say we want to write a list comprehension that is going to generate all of the pairs of odd and even numbers up to from 1 up to 10. So we combine things like 3 with an even number like 4 or 8 or 6, whatever it is. So let's see how we would do that. Because we're working in Haskell, we can specify the shape of the elements of the list just by giving Haskell a general idea. So we don't have to specify anything too wild. We can just say it's going to be of the form x and y. So you're going to have two values, an x and a y, and they're going to be the elements of this list. So this tells Haskell it's a tuple without you having to explicitly say any more. So I can say x comes from the list of even numbers, so this are odd numbers. I said odd first, so we should follow that. So it's going to be the odd numbers up to 10. I'm going to say y comes from the even numbers up to 10. So I don't actually, I can apply the logical conditions. I could do like x mod 2 equals 0, or I could say that y mod 2 equals 1. I could do that if I wanted to. It's up to yourself, but this is just a simple way to generate the odd and even numbers. So if I save this and then I go into odd even in terminal. Oh no, I need to reload first. a classic mistake in Haskell. Make sure that you're reloading your file when you're testing it, otherwise you can get error messages that are out of date. I do that a lot of the time, so make sure you don't. That's my key piece of advice. If I hit odd even, I get all of the pairs. And you can see that it takes the generator of the first argument, x, and combines the first element of that with every element of y. So we take 1 as the first odd number, and then combine it with every even number. And then we go to the next odd number, which is 3, do the same again, and the next odd number, do the same again, and so on and so forth. So this is quite a simple way to build up a slightly more complex list. We can also turn this into a function if we want. Say if we wanted to generate all of the odd and even pairs up to a value n, we can change this very simply by adding an argument here, and then changing the limit of the range to be n, or the generator, whatever you prefer. Now I have a function rather than just a list. So if I reload and I hit odd even, and let's say we go up to 8. I'll get a shorter list than before, but it's just to show you that this will cap out at 8. I can also do this with a much larger value. I could do this with 80. It takes a wee while because there's quite a few pairs in there. But that's another simple way to do this. Now another thing you can do over here is you can manipulate the shape of the elements of the list in here. So let's say we want to generate from a list of all of the characters A to Z. I want to combine them with another character that's not the same as it. So for example, if that's a little bit confusing, I want to have A combined with every other. So I want a string that looks like AB, and then another one which is like AC, AD, so on up to AZ, and then I do the same with B, but I never get AA or BB. So I combine every character with every other character that's not the same, where they're not the same. So let's have a look at this. We can do list car, let's call it. And I'm going to leave this bit for the moment. We're going to come back and fill this in. I'm going to say x and y. And I'm going to say that x is going to be taken from the generator which says A dot dot to Z. So I'm going to go all the way up to Z. And then I'm going to put another comma, put in another generator, and say that y is going to be coming from the same list. You might be wondering if you could do this with one argument, as in just like take x and then work with x itself, but if we want to test to make sure that they're not the same, we need two variables to compare to each other, because x will always be the same as x. And we want to say such that x does not equal y. So as long as they're not the same, we combine them. So that's okay. We've figured out how to get each of the characters, and then we'll put in the logical condition that we need. So we're getting all of the characters, and we're restricting to the cases where x and y are not the same. So how do I combine them? Well, in here, similar to what I did up here, I can apply operations to these two elements. So I know that a string, if I'm combining two characters, I'm going to have a string. I can use the cons operator to stick them together. So I stick two elements together using that cons operator. But if I want this to form a list, I need to then cons onto the empty list. So I can stick them together like that, and then if I reload and I do list car, you can see that I get all of the pairs of characters such that they are not the same. So I get AB, AC, but I don't get AA, and then at the end here I get BA, but I don't get BC, or BB, sorry, I just get BC next. So you can see these are a relatively good way to, or a relatively powerful way to build up more complex lists. These are quite simple examples, but I just want you to get used to the ideas that you can have generators that are not necessarily just integers. They can be characters in this case. They can also have a limit that is set by a function argument, and you can have as many predicates as you want. You can also have more than one generator in a list comprehension. So that's everything for today. I hope you found this useful. Of course, if you have any questions about what I've covered here today, please do feel free to get in touch. Thanks.